welcome back. I'd like to especially welcome all my new subscribers, and I hope you enjoy the content on my channel. If you missed part 1 of the tool holders video, you can go watch it up there now. I decided to split this up. It was going to be a single video, and I decided to split it up because it took me a long time to make the parting tool holder. It is kind of my own design. I don't think I've ever seen one like it. I've seen similar things, but follow me over to the mill and we'll get on with it. And I hope you enjoy this one. Over there. Alrighty, so that's all the roughing work done. You're wondering what the hell I'm doing here. I'm doing what I normally do and I'm making up as I go. I don't really like the way that little aluminium thing works. It just relies on being able to clamp the thing in there with nothing to stop it from twisting out at all. But this blade has ever so slight bevel on one edge. So what I'm going to do is at that edge there is I'm going to get the slitting saw out and I'm going to put a little slit in here, not real deep, maybe a mil at most, and then I'm going to get that little 60-degree dovetail cutter out. I'm going to put another little bevel in there, and down in here I'm going to put the slitting saw through there as well, a couple of times maybe, and then cut a bit of a dovetail in there. So, and then I'll make a cap that bolts down over the top of this with a little overhang to grip this top edge, and a dovetail on the back edge of it, so that when you tighten it bolts down to grip it, the dovetail will pull it back in and hopefully pull that back towards the side and clamp it. So that's the thought anyway, so that's what I'm going to do. Alrighty, so that's the bulk of the machining done. I didn't video much of it because it's taken forever. I had to do it the hard way because I couldn't get the slitting saw in here, even with modifying the retaining cap. I put a bit of time into modifying that and I still couldn't get it in there. So I would have to turn it all around this way, and even then I would have struggled to do the top one. So what I've done is, the top one I've gone in 0.75 and then slowly came up and up and up until I created a flat in the bottom. And let me see which edge is it. Alright, that's the tapered edge there. That fits nicely up in there now. Alright, so I can't rotate it out of there. I've got to mill a bit off this face here yet just to clean it up because it's a bit too wide, and it's got to have a good mil or mil and a half taken off that yet. And then the retainer will have some bolts in it, so that when you bolt it up, it will pull it down in towards the body here. Well, that's the theory. So if you still can't understand what I'm trying to do, you will when I'm finished. Alrighty, quick update. So I've got this piece here. It's 10mm thick. It's actually the piece I cut out of the centre of the Z-axis. Piece of that. I have machined this side, and fly cut this side, and mill one of the ends off. I'm now going to undercut this, maybe millimetre or so. This edge here will be the bit that hangs over blade to pull it in. There's way too much there, but I'm not going to mill that off because I need something to hang on to. And once I have it all bolted up in the tool, then I'll put the whole tool in here and just mill off any excess that's on there. But that's what I'm up to. So now I'm going to put a milled bit out of here of maybe a millimetre or a millimetre and a half, something like that. Well viewers, I have to admit to having nearly stuffed this thing up before. When I started machining that flat in there, I shouldn't have been machining a flat, it should have been machining a slot. Anyway, I rescued it just in time. Anyway, now I'm putting that bevel on. Well, I'm going to settle on that, so I'll take it out of there and give it a quick deburr and go over the vise and see if it's going to work. Alrighty, looking at that, I'm going to have to take some wire out and go all the way to the bottom, I think, because they'll just want to kick down like that when I tighten it up, which is not what I want. By Jove, I think I've got it, but I won't know for 100% certain until I put the bolts in and tighten them up, but I think I got it. Alrighty, now for the hard part. Hoping like hell that this doesn't move. Got that pinched in there well and truly, and I want it to stay where it is. Alrighty, so there's the pilot hole successfully done. I'm going to go find the right tapping size drill. Well viewers, there it is. I've only got one bolt, I'll have to go and buy some more. But that worked exactly as I planned it to work. So as I tighten it up, it pulls it in, clamps it in there well and truly. So even with only one bolt in there, it's well and truly locked in there. So I'm pretty pleased about that. So I'll get in the road and I'll get some more bolts, and then I can clamp it back in the vise, and I'll just mill this off the side till it's about the same height as that. Might even take a little bit off that one while I'm at it. Anyway, that's that. Alrighty, so while I've still got this drill chuck in here, I'll drill this hole for the adjustment screw. Picked up this cute little T-bar a while back. Lovely little thing it is for these small taps. These would normally be M6, these bolts, but I don't have a lot of meat there, so M5 it is. In all truthfulness, this particular hole though, I could have done without not taking the 1.5 mil off one side of it. Would have made life a lot easier. I don't think it's deep enough. Alrighty, so next cab off the rank will be to get that chuck out of there and put a milling cutter in and face this thing down to size. I think that will do it. I don't want to take much more off than that. Rightio, so the next step will be to go and make a couple little brass fine adjusting wheels for the tops of these things. If you've been enjoying this video up until this point, how about doing me a great big favour and smashing that like button. And I knurl it with my cracky Chinese knurling tool. Isn't that the epitome of laziness? Well, that's not brilliant, but it'll do. Earls and Earls and Earls. Well, I should do something about drill a hole in, I suppose. That was pretty stupid. Turned the wrong bloody handle. Oh, shit happens and it doesn't matter. I should have ground up the new one and had a go at parting it off with that. That doesn't matter, we'll use this one. A little bit of brass, shouldn't give me any dramas. Quick deburr on the bench. There you go, look at that. Good old Uncle Bobby. Right now I'm going to make a confession. I stuffed this up. When I had problems in here with that milling cutter, I didn't go back down to the 0.6 up from here, and subsequently I've cut that dovetail too far up. And now it doesn't quite lock up. So I don't think it's a major issue. I'll just make up a little shim I can slip in down the side of there or in here, so it'll lock up. In fact, I'll do that right now. Alrighty, so I'll just cut this little tab up. And don't fall into the same trap I fell into there. Stick to your dimensions if you're making these things. Double check everything. Measure twice, cut once. That's the old saying, isn't it? Measure twice, cut once, and just pushed it down in there. Good as gold. So that's almost done now. We need a nut on the top. The only thing left to do is get that bloody mill scale off there, clean up the rest of it a bit, and put some cold blue on it. Well viewers, as they say in the classics, the proof is in the pudding. In this case, in the parting. I've already taken a little cut and edges so I could chamfer the edges before I part it off. I ground this tool up, and I ground it the way we used to grind it back in the factory, with a 15-degree angle on the face, back this way. When you're making 500,000 fittings a year, sometimes more than that, and a lot of them are flat on the back, no hole, no through hole, you don't want to be removing 500,000 little tits off the back of the damn thing. So you want to make sure that your parts come off without a tit. So the idea was that this edge here is the leading edge, and it would drop the part off and then continue on, finish facing it off. I've got to say that this tool was cutting so much cleaner in there than the little cardboard one I normally. It normally goes dig, 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 dig all the way, and this is just cut as smooth as. It's a little bit of irony in what I was just talking about there. We used to make tens of thousands of quarter BSP plugs. We used to wonder, do people drill and tap quarter BSP holes just to put a plug in it? We sold so many of them. But the irony is, we used to pump those things out in our old BSA cam autos in 5 seconds or 6 seconds, can't remember. Now, when we switched to CNCs, they used to take 35 seconds. It was kind of, so we could actually make a whole BSP plug in less time than it took me to part that off. And as you can see, there's very little left on there to clean up. In the cam autos, we had a tool we used to poke up inside and chamfer the back of the hole before we threaded it, if there was a thread in the back. And in the CNCs, we used to use boring bar and just get up in there and chamfer the back of the hole before we thread. Anyway, that's them, and so I'll get this back out of there now, clean it all up and give it a blue. Well, there it is folks, all done. Thought I'd put a sheet of white paper here so you can see a little better. That little brass knob sets it off nicely, I think. But anyway, it was a lot of work, but well worth it, I think. So thanks for hanging in there, and I hope you really enjoyed it and maybe you learned something from it. If you want to copy this, then feel free to copy it. And like everything I do, there's no plans for it, so you'll have to just work it out from my drawings or ask me about it in the comments. So that's it. Thanks for watching, and bye bye for now.